Dear friends, in this video, I address Boxplot with its associated concepts. Boxplot is based on the 5 numbers summary or 5 summary measures, namely the smallest value of the data set, the first quartile Q1, the median value of the data set, the third quartile Q3, and the largest number in the data set. 5 measures of central tendency and quartiles, you might say, because the percentile concept, if you apply, Q1 represents the 25th percentile, median is the 50th percentile, and Q3 is the 75th percentile. And the box plot, the very name suggests there is a box. The edges of the box represents Q1 and Q3. The middle part is the median. It is not necessary that median is always exactly the divider, the central line. In other words, in a perfect situation of a bell curve, the median will be exactly in the center of the box. In other cases, depending upon the right skewed pattern or the left skewed pattern, the position of the median will change. So this is the basic idea. And then what happens here is, I take the interquartile range, which is the difference between Q3 and Q1, subtract it from Q1. So Q1 minus 1.5 times IQR. I add the interquartile range 1.5 times to Q3, which becomes Q3 plus 1.5 IQR. And in this interval of Q1 minus 1.5 IQR to Q3 plus 1.5 IQR, if all the data points fall, then there is no outlier in the data. Even if one of the data points falls outside this interval, it's called an outlier. Extreme value. The box plot has the capability to detect and directly point out the outliers in the data. In other words, it is not necessary that the smallest value is not the outlier. In other words, the smallest value could very well be an outlier if it violates this condition. Likewise, the largest value could very well be an outlier if it violates the condition, becomes greater than Q3 plus 1.5 IQR. In other words, any data point that goes outside this interval is an outlier. It's a very important tool in research also. The shape of the distribution could be easily understood by the box plot. Let's look at some shapes now. Left skewed, symmetrical, right skewed. So what you do here is the box plot. This is Q1 minus 1.5 IQR. This is Q3 plus 1.5 IQR. These are the boundaries out of which the data point is declared as outlier. So you can see this here. Left-hand side of the median, left to the point Q1 minus 1.5 IQR, this part is longer than this part. Therefore, it is left skew. Here, all are equal, so it is symmetrical. In other words, median to this point, median to the left side fence, all are equal. perfect symmetry. This is right skewed. From the median to Q3 plus IQR, this portion is longer than this portion. Therefore, it is right skewed. Now, let us apply the box plot for the data which we have already considered TARC problem. So I'm not reading it again in a detailed way. You know the problem. It's to study the high level of rejection, and we have done it for measures of central tendency, dispersion, histogram. Also, we are going to do. So the same example we'll be using for the box plot. So now what is the position? We use the Jupyter note in the Python language. Import pandas as PD, import warnings. Warnings.filter warnings ignore so that warning message doesn't unnecessarily come and trouble us and frustrate us. Then TARC is entered with its data values, which is a column vector. So I declare it as a data frame, pandas, using PD is the short form. Then I put my data.columns, name TARC, I give. Then graphics, software library, import Seaborn, import Matplotlib in short form as SN. Here as PLT, I just enter and simply write it there. Then the command SN dot boxplot, my data.tarc, color is equal to red. So SN dot boxplot is the command for constructing the box plot. Plot.show, I put here. Let's see how it comes. This is the box plot for the example. As you see here, the smallest value is 8, the largest value is 20, but the smallest value becomes an outlier. In other words, there is no outlier on the right-hand side, so it's perfect, so okay. But there is an outlier here because the boundary allowable is around 10, which is Q1 minus 1.5 IQR. This number is smaller. It's outside this interval. Therefore, the minimum value of the data set is an outlier. You need to center it because it is right skewed, as you can see, and a little bit adjustment is required to center the process. It's not bad, but it's not a perfect bell curve. Center it is a corrective action that you can take. So this is the concept of box plot, a magnificent output, very easy to do in Python and interpret the results. You can construct comparative box plots for comparing different groups in the same picture. You can have 3 groups. All those things we can do. They're all pretty simple, but the idea is to understand what is the box plot. The 5-number summary pictorial representation visual, in a way it gives the pattern and shape of the distribution. It also helps to detect outliers. Thank you. We will see again soon in the next video. Thank you very much.